Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is your instructor Anisa Nawaz from Department of Physics. This is our lecture number 24 from chapter number 2, Vectors and Equilibrium. In previous lectures we have discussed about Cartesian coordinate system, vectors, some types of vectors, vector addition, different ways to add the vectors, vector multiplication which included scalar product and vector product, torque, equilibrium and conditions of equilibrium. Now we will move towards the exercise in which first we will discuss about multiple choice questions. In multiple choice questions we will first discuss about multiple choice question number 1. Two vectors lie with their tails at the same point. Okay, their tails are joined. When the angle between them is increased by 20 degrees, their scalar product has same magnitude but changes from positive to negative. The original angle between them was option A 0, option B 60 degrees, option C 70 degrees and option D 80 degrees. Okay, so what we will do, we will check this out. They are saying that we are having two vectors which are connected by their tails. Okay, we are having two vectors which are connected by their tails and we are taking their scalar product. A dot B is equal to AB cos theta. Okay, let's say that we are having this as Cartesian coordinate system in which vector A, we can draw it anywhere. Let's say this is our vector A. Okay, and what is there? We are having another vector B and we have to find out the angle between vector A and vector B. You can see over here we are having four options: 0, 60, 70 and 80. And they are saying that if we are increasing the angle by 20 degrees, their scalar product has same magnitude but changes from positive to negative. It means that a result of cos theta remains, its magnitude remains same but its sign changes from positive to negative. What does it mean? It means that if these two angles are lying in the first quadrant, then by adding 20 degrees they should move towards the second quadrant. The angle between them should be increased, should be greater than 90 degrees if the magnitude has to change from positive to negative. You can see over here, if the angle between two vectors is 0 degrees and we are adding 20 degrees, then 0, cos of 0 and cos of 20 degrees, they are having, both are having positive magnitude. Okay, because it is remaining in first quadrant, it is not changing. If we are having 60 degrees and we are adding 20 degrees in that will give us 60 degrees and 80 degrees, both will give positive magnitude. The sign is not changing in this case as well. If we are having 70 degrees, cos of 70 degrees, and if we are adding 20 degrees in that will give us cos of 90, that will give us 0. Magnitude is again not changing from positive to negative. So what should be the correct answer? Correct answer should be cos of 80 degrees. You have to solve it as well. You can put the value in place of theta. That will be cos of 80 degrees and cos of 80 plus 20, that is 100 degrees. You will see that magnitude of cos of 80 and magnitude of cos of 100 degrees will give you the same result, but what will be there? There will be just a difference of sign. Okay, if we say, if we are going to calculate the result with the help of calculator, then what we will get for cos of 80, what we will get result is positive. Okay, that is 0.174. okay, and cos of 100 is minus 0.174. so if we are going to verify the result for this cos 80, that will be positive and negative. Okay, in both the cases. So we will say that if you're having another angle, then the original angle between A and B is 80 degrees. Result is theta is 80 degrees because cos of 80 degrees and cos of 100 degrees is having same magnitude, but their sign is opposite. Okay, so what we have done, we have calculated the correct option as option D. Okay, you can simply see this thing that if we are having these four options and only one option is there which is changing the quadrant, which is giving us the resultant angle which is lying in some other quadrant, then it means that that should be the correct option because it is changing the value of theta, it is increasing the value of theta from one quadrant to another quadrant. 80 degrees lies in first quadrant and 100 degrees lies in second quadrant. Okay, this is not the case with any other option, so option D is the correct option. Check out MCQ number 2. The minimum number of vectors of unequal magnitude required to produce a zero resultant is 2. If we are having say option A 2, option B 3, option C 4 and option D 5. Okay, so if we are having unequal vectors, then two vectors will never ever give us zero resultant. Okay, so option 2 is excluded. Okay, let's check out for option 3. If we are having three vectors of unequal magnitude, then you can see it is giving us a resultant 0. So what we can say, the minimum number of vectors of unequal magnitude required to produce a zero resultant. You can see these three vectors are forming a closed figure. Their resultant is a null vector, their resultant is 0. Okay, so we will say that the minimum number of vectors required to produce a null vector, required to produce a zero resultant is 3. Okay, so they are asking about minimum number, so there is no need to calculate for 4 and 5. Okay, 2 is not possible, so 3 is the minimum number of unequal magnitude vectors which give us the null vector. MCQ number 3. If the resultant of two vectors, each of magnitude A, is also magnitude A, the angle between the two vectors will be 30 degrees, 45 degrees, 60 degrees and 120 degrees. Okay, they are asking that we are having two vectors that are having equal magnitude and resultant is also having same magnitude. What will be the angle between the vectors? Okay, if you remember that we have done this thing that we have calculated example 2.3, find the angle between two forces of equal magnitude such that the magnitude of their resultant is also equal to either of them. We have calculated, we have solved this example and our result was 120 degrees. So over here same is the case, we are having two vectors of equal magnitude, magnitude of their resultant is also equal, which is 120 degrees. So if we are having any two vectors and their resultant which is equal in magnitude, means that they are forming an equilateral triangle. Two vectors and their resultant, they are forming an equilateral triangle, then the angle for them should be 120 degrees. That is easy for to remember for you people, that if we are having an equilateral triangle and we have to divide total angle in that triangle. Okay, so what will be there? The angle between those two vectors should be 120 degrees. We have calculated that. Okay, if you are having two forces of equal magnitude such that magnitude of the resultant is also equal to either of them, you have to learn this value. MCQ number 4. The magnitude of vector A is equal to 2i hat plus j hat plus 2k hat is option A 9, option B 5, option C 3 and option D 1. We have to calculate the magnitude of the given vector. You can see that we are having this vector A in which x component is 2 with I hat. You can see that this is the value of x component. J component is having value 1. You can see j hat is telling us about the direction and its magnitude is 1, and 2 is the magnitude of z component. Okay, k hat is telling us about the direction and 2 is the magnitude of z component. We have to calculate its magnitude of the vector a. You know that the formula, first we will write down value of ax, ay and az. Okay, and then by rectangular component the formula for magnitude is magnitude of vector a is under root ax square plus ay square plus az square. You know this formula of magnitude. So when you will put the value of ax, ay and az over here, 2 square plus 1 square plus 2 square, okay, we will get 9. Under root 9 is 3. So magnitude of a will be 3. So when you will solve this formula, you will get the result magnitude of vector a is 3. Okay. Number 5, when Fx is equal to 3 Newton and F is equal to 5 Newton, then Fy is equal to what? Option A 6 Newton, option B 4 Newton, option C 2 Newton and option D 0 Newton. What is given? X component is given and resultant force F is given. We have to find out the Y component. Okay, so what we will do, if we are going to solve this, we will simply use the formula again, same formula which we have used for magnitude. F square is equal to Fx square plus Fy square. Okay, so what we will do, F is given, Fx is given, we can separate out Fy. Fy square is equal to F square minus Fx square. If we are going to put the values of F and Fx, we will get 5 Newton square minus 3 Newton square, and after solving we will get Fy is equal to 4 Newton. Okay, we will subtract the values and we will take under root on both sides. We will get Fy is equal to 4 Newtons. So correct option is 4 Newton, option B. MCQ number 6. A meter stick is supported by a knife edge at the 50 centimeter mark. Its center of gravity is 50 centimeters. RF hangs masses of 0.40 kilogram and 0.60 kilogram from the 20 centimeter and 80 centimeter marks respectively. We are having a rod in which two masses are being hanged over here. Where should RF hang a third mass of 0.30 kilogram to keep the stick balanced? Okay, so 4 options are given: 20 centimeter, 70 centimeter, 30 centimeter and 25 centimeter. So what is given value over here? We are having a meter rod which is balanced at 50 centimeter mark. Okay, so this meter rod right now it is balanced at 50 centimeter mark. Then what is there? Two masses, one of mass you can say 0.40 kilogram and second one of 0.60 kilogram. They are hanging from this meter stick. 0.40 kilogram is at 20 centimeter mark and 0.60 kilogram is at 80 centimeter mark. Okay, so this mass, where it should be hanged so that the meter rod is not disturbed. Initially when there were no masses, this meter rod was balanced at 50 centimeter. Then two masses were hanged and there you can say equilibrium is disturbed because this mass is different and this mass is different, although the distance is same. If it is at 50 centimeter mark, okay, so distance from 50 to this 20 centimeter mark is 50 minus 20, that is 30 centimeter, and over here 80 minus 50, again 30 centimeter. Okay, so distance of these two weights, these two masses are equal, but the magnitude of the masses is different. Okay, as you can see this mass is less. So next the mass, third mass which we are going to hang over here, it should be on this side. It should be on the side of this lighter mass. That's why we are just roughly placing this mass over here. Okay, we don't know what is the exact value, what is the exact mark on the meter rod, but we are going to hang it on this side. So over here we will use second condition of equilibrium. Let's say this is first mass, this is second mass, and this is third mass, unknown mass. Okay, so first mass, you can see that it is giving us anti-clockwise rotation. This is giving us anti-clockwise rotation, so it is with positive sign. This T2, this M2 is giving us clockwise rotation, so this is with negative sign, and this unknown mass is also giving us anti-clockwise rotation. That's why it is with positive sign. Tau 1 minus tau 2 plus tau 3, that is 0. So we have to separate out this tau 3 because we need the distance R3. So we are using the formula of torque. Tau is equal to R cross F, and force over here is weight. W3 into R3 is equal to minus W1 into R1 plus W2 into R2. We are putting value of weight. W is equal to mg because we are provided with mass. Okay, we are not given the value of weight, but we are provided with the value of mass. So we will put the formula of weight m3g, m1g and m2g in place of W3, W1 and W2. You can see g is common on both sides, so it will be cancelled, and we are left with this value m3 into r3 is equal to minus m1 r1 plus m2 r2. What is the unknown value? That is r3, where we know that m1 is 0.40 kilogram, m2 is 0.60 kilogram, m3 is 0.30 kilogram, r1 is 30 centimeter because 50 minus 20 is 30. R2 is again 30 centimeter because 80 minus 50 is 30. What is R3? R3 is equal to 20 centimeter. After we will put all these value in this relation, we will get R3 is 20 centimeter. Okay, distance between this unknown mass and this center of gravity. But this distance is not required. They are asking about where should RF hang a third mass. We have to find out the mark. So we will subtract this value, this 20 centimeter from 50 centimeter to find out the mark. 50 minus 20 centimeter will give us 30 centimeter. Okay, this 20 centimeter is the distance, it is not the mark. So distance between this central point and this mass is 20 centimeter. So we will subtract that distance from this 50 centimeter mark to get this value. So 50 minus 20 will give us 30 centimeter. So this mass is hanged at the mark of 30 centimeter. So option C is the correct option, 30 centimeter. Okay. Number 7, if AX is 1.5 centimeter, AY is minus 1 centimeter, into which quadrant do the vector A point? That's very simple. First, second, third or fourth quadrant. You know X is positive, Y is negative. So what should be the quadrant? You know in first quadrant both X, Y are positive. In second, X is negative, Y is positive. In third quadrant both are negative, and fourth quadrant X is positive and Y is negative. So here you can see X is positive, Y is negative. So it will lie in which quadrant? Fourth quadrant, plus minus. Option D is correct. Number 8, A dot A cross B is equal to what? Option A 0, option B 1, option C AB, and option D A square B. What is the option? You don't have to solve it completely, just you have to use the basic concept over here. We know that A dot A cross B, what it will give? If we say that A cross B, that will give us a vector perpendicular to the plane containing A and B. Over here it should be a vector perpendicular to plane containing A and B. So A cross B is basically a vector which is perpendicular to both A and B. Okay, so it is a vector perpendicular to A as well, because we have to take dot product with A. So a vector perpendicular to A in this case. So theta is 90, A, and a vector perpendicular to A. So angle between this A and result of A cross B is 90 degrees. Okay, now A dot, let's say vector C, A dot C will be having an angle of 90 degrees. Okay, so we have to find out cos of 90 degrees, which is 0. So result of this product A dot A cross B is always 0. Option A is correct. okay, because A cross B is giving us a vector perpendicular to A. So A dot that vector will be having an angle of 90 degrees. So if we are going to find out dot product, cos of 90 is 0. So A dot A cross B is always 0. Number 9, two forces of magnitude 20 Newton and 50 Newton act simultaneously on a body. Which one of the following forces cannot be a resultant of two forces? Option A 20 Newton, option B 30 Newton, option C 40 Newton, and option D 70 Newton. So two forces are there, 20 Newton and 50 Newton, okay, and they are asking that which force cannot be the resultant. Okay, so how we are going to find it out? We should know this thing that if we are having any two forces and we are going to find out their resultant, maximum value of resultant could be the sum of these two values, that is giving us 70 Newton, and minimum value of resultant could be difference between the two given vectors, 50 Newton minus 20 Newton. You can see over here that the magnitude of the resultant could lie between the value 30 Newton and 70 Newton. All the other values except 20 Newton are lying within this interval, 30 Newton and 70 Newton. So this option A 20 Newton is basically the option which could not be the resultant of two forces, okay, because it is not lying within the interval 30 Newton and 70 Newton, okay, sum and difference of the given forces. The resultant could lie between sum and difference of the two given forces. You should keep this in mind. Number 10, if the dot product of two non-zero vectors A and B is 0, then the magnitude of their cross product is 0, 1, AB and minus AB. If the dot product of two non-zero vectors is 0, what does it mean? If dot product is 0, it means that theta is 90 degrees. Cos of 90 is 0. That's why angle is 90 degrees. And in cross product, if angle is 90 degrees, then sine of 90 is giving us the maximum value. Then we can say that what is their cross product is maximum. Maximum product is AB. So we will get this option C is the correct option, okay. Option C, AB is basically the correct option which is giving us the maximum magnitude because theta is 90 degrees. So in case of cross product, when theta is equal to 90 degrees, we get the maximum magnitude. Number 11, the sum of magnitudes of two forces is 16 Newton. If the resultant force is 8 Newton and its direction is perpendicular to minimum force, then the forces are either 6 Newton and 10 Newton, 8 Newton and 8 Newton, 4 Newton and 12 Newton, 2 Newton and 14 Newton. You can see sum of all these forces are 16 Newton. So anyone could be the correct option. Let's check out what we are going to do. We will draw the figure. If we are having two forces, let's say force F1 and second force, obviously it will be 16 minus F1, okay, because sum of these two forces is basically 16 Newton. So one is F1 and second is 16 minus F1. So let's say F1 is the smaller force. We don't know which one is smaller, but let's say F1 is the smaller force and the resultant is perpendicular to this smaller force. Resultant is 8 Newton and it is perpendicular to this smaller force. We have to find out the value of forces. According to given condition, sum of two forces F1 and F2 is 16 Newton. So F2 is equal to 16 Newton minus F1. Okay. F1 is smaller force. Over here, we can apply Pythagoras theorem. F1 is, we will get the result, F1 is equal to 6 Newton. You can see in this triangle, this is hypotenuse, this is base, and this is perpendicular. So hypotenuse square is equal to base square plus perpendicular square. You have to solve it. You have to solve it step by step and you will get F1 is equal to 6 Newton. F2 can be calculated easily. 16 minus 6, that will be 10 Newton. You have to apply Pythagoras theorem over here, okay. This square is equal to F1 square plus r square. So calculate, find out F1 and then you can calculate F2. So option A, 6 Newton and 10 Newton is basically the correct option. You have to solve it yourself, do the calculation yourself, and you will get this result by applying Pythagoras theorem. Number 12, find the mass of the uneven rod shown in the figure. If its center of gravity is 14 cm from end A, mass of rod either is 100 grams, 150 grams, 80 grams or 5 grams. We are having an uneven rod. You can see in the figure we are having uneven rod. It means that its mass is not lying at its center. So if it is having, you can see over here, it is balanced on the wedge. Its center of gravity is lying over here, 14 cm from end A, and between end A and center we are having 30 cm length, and between center of gravity and this mass, between balance point and this mass we are having a distance of 20 centimeter. Okay, and they are asking what is the mass of this uneven rod. So again over here we have to apply the condition of equilibrium. Second condition of equilibrium, basically we have to calculate this mass. We will take sum of all the torques is equal to 0, or you can say sum of clockwise torques is equal to sum of anti-clockwise torque. Or with that we will calculate the mass. Okay, for equilibrium, tau 1 should be equal to tau 2. Okay, torque produced due to this mass and torque produced due to this mass, it should be equal. We are putting the value W1 into R1 is equal to W2 into R2. Again putting the value of weight mg. W1 is m1g, W2 is m2g. G will be cancelled. M1 into R1 is equal to M2 into R2. By putting the values over here, you can see M1 mass, let's say M1 is 80 gram. 80 gram into R1, that is 20 centimeter. So 80 into 20 is equal to M2 multiplied by this distance. But this distance is not given. We are provided with 14 centimeters. So we have to calculate this distance. 30 minus 14, this will be the moment arm. 30 minus 14, so we will put it R2 over here. We will get 1600 is equal to 16 M2. So if 1600 is divided by 16, we will get the result 100 grams is the correct option. We have to apply a second condition of equilibrium. As this rod is balanced, so clockwise torque must be equal to anti-clockwise torque. We have just placed the formula over here. W1 into R1 is equal to W2 into R2. Then by putting the values, we have separated the mass and we have calculated that mass. Okay, just put the condition of equilibrium. Number 13, the following diagrams show a uniform rod with its midpoint on the pivot. Two equal forces F are applied on the rod as shown in the figure. Which diagram shows the rod in equilibrium? We are having this diagram. You can see which one is showing the condition of equilibrium. Over here, A, you can see clockwise, the torques, they are producing a couple over here. So this rod is not in equilibrium. It is having a tendency to rotate. Over here both forces are in upward direction, so this rod is having a tendency to move. It is having a tendency to have translational motion. This rod again producing a couple. What about this rod? We are having clockwise torque due to this force and anti-clockwise torque due to this force. So clockwise torque is equal to anti-clockwise torque. So this rod is in equilibrium. So we will say option C is the correct option. This rod is in equilibrium. Number 14, for which angle the equation magnitude of A dot B is equal to magnitude of A cross B is correct? 30 degrees, 45 degrees, 60 degrees and 90 degrees. If this is given, this value is given without magnitude, then this thing is not possible. A dot B can never be equal to A cross B, but their magnitudes can be equal. Okay, A dot B, magnitude of A dot B can be equal to magnitude of A cross B. So if we are talking about the magnitude of A dot B and magnitude of A cross B, then we can write it as AB cos theta is equal to AB sin theta. AB is cancelled on both sides, we will get cos theta is equal to sin theta, or we can divide sin theta by cos theta, which will give us tan theta. Tan theta is equal to 1, and if we are going to separate out theta over here, theta is equal to tan inverse of 1, which will give us 45 degrees. So at 45 degrees, magnitude of dot product and cross product is equal. And last MCQ number 15, what is the net torque on the wheel radius 2 meter as shown in the figure? 10 Newton anti-clockwise, 10 Newton meter anti-clockwise, 10 Newton meter clockwise, and 5 Newton meter clockwise. You can see over here option A is excluded because Newton is not the unit of torque. Newton is the unit of force. So option A could not be the correct option. We have to check out which of the rest options is the correct one. This is the given figure. We are having a wheel of radius 2 meters. You can see over here, if this is the center of the wheel, this radius is 2 meter and this radius is 2 meter. Okay, so this force of 5 Newton is producing a torque of 5 into 2, and torque, this 10 Newton is producing a torque 10 into 2. So if we are finding out net torque, it is not in equilibrium, we are having some net torque. Okay, so how we are going to do that? We are having sum of all the torques. This is not equal to 0, this is producing some net torque. As clockwise torque is negative, so we are placing negative sign with that, and anti-clockwise torque is positive, so we are placing positive sign with that. We have calculated the value of clockwise torque. You can see over here, this 10 Newton force is producing a clockwise torque, so we will write it as minus 10 into 2. You can see minus 10 into 2. Okay, and plus anti-clockwise torque plus 5 into 2. You can see over here plus 5 into 2. So after taking summation of these two torques, we will get the result, we will get the net torque. You can see that will be minus 20 Newton meter plus 10 Newton meter. This is equal to net torque. That is minus 10 Newton meter net torque. So magnitude is 10 Newton meter, but whether it is clockwise or anti-clockwise, you can see over here we are having a negative sign, and negative sign is showing us this thing that this torque should be in clockwise direction. So net torque is 10 Newton meter clockwise. Option C is the correct option, 10 Newton meter in the clockwise direction. Okay, so we have just again put the second condition of equilibrium, which is sum of all the torques is equal to 0. Okay, so I would like to end my lecture with this quote: failure is not fatal until we surrender. Trying again is the key of glorious victory. So try again. If you are not getting anything, then you have to try again and again for that thing. Never surrender for that, because this try again, that is the key of glorious victory with which you can achieve your goals. Best of luck to you people. That was all for today's lecture. Thank you so much.